Okay, this is for response 1B. It says a solution of the soluble salt nickel 2 chloride, and it gives us the formula, so NiCl2, and it says it's soluble, so I'm going to put aqueous down below, is poured into a solution of potassium phosphate, so it tells us this is a solution as well, so I'm going to put aqueous there, to make a precipitate of nickel 2 phosphate. So the nickel and the potassiums are going to swap partners right here, and I'm going to get nickel and phosphate together, and this is going to be a solid, but be careful, make sure that you write this formula correctly, knowing that nickel is positive 2 because it tells us it's nickel plus 2 right here, and then phosphate is on the back of the periodic table here, and remember that is negative 3. So if this is plus 2 and this is negative 3, it means I'm going to have 3 nickels, and I'll have to have 2 of the phosphates. So be careful when you write that formula. And then the chlorine goes together with the potassium. Always write the cation first, so the potassium's plus 1, which you can find on the periodic table right here in group 1. And then the chlorine is from group 17, so that's minus 1, so 1 and 1 for that. Okay, so this is our skeleton equation. We also know that potassium chloride is going to be soluble because all alkali metal cations are soluble, and that includes potassium. It's also soluble because chlorides are soluble. And then we will balance it by putting a 3 for the nickel, which gives us 6 chlorines, which means we're going to need a 6 for the chlorine right here. But that gives us 6 potassiums, so we'll need a 2 for the potassium here, 2 for the phosphate, a 2 for the phosphate right here. So there's our balanced skeleton equation, and now we can go ahead and separate them into a net ionic, so 3Ni plus 2 plus 6 Cl minuses. Notice how the 3 distributes to the 2, and you have to multiply those to get 6, and then you get 6 K pluses and 2 PO43 minuses. So notice how the 2 distributes in here. And then this stays together because that's a solid. So Ni3 PO42. And then the 6 distributes in here, so we get 6 K pluses and 6 Cl minuses. So this is our complete ionic equation. Notice that the 6 Cl minuses would cancel and the 6 K pluses would cancel. And so we end up with the nickels, the phosphates, making nickel phosphate right here as our net ionic equation. And you'd want to rewrite that on a test. And then the last one, or the next one, is for response 1, letter C. This one says a solution of concentrated hydrochloric acid, and it's a solution, so it's aqueous, reacts with the weak base ammonium hydroxide, so NH4OH, to form water and a salt, so we're going to get HOH, and we're going to get a salt of the chlorine together with the ammonium, and the ammonium is going to have to be written first because that's a cation, and if you forgot that ammonium is plus 1, you can look on here and you can find it right up here at the top, and then chloride is going to go with it, and that's minus 1, chlorine is in group 17, and that's minus 1 right here, and then it says that this is a weak base solution. Water, of course, is a pure liquid, and ammonium chloride is going to be soluble because all chlorides are soluble, and also all ammonium salts are soluble right here as well. Okay, so then when we go to split this up, we're going to split up the hydrochloric acid. Whoops, just check to make sure that it's balanced. NH4, NH4, 2 H's, an H and an H and an O right here. Okay, so we split up the strong acid, H plus and Cl minus. And then this guy, it tells us is a weak base. It says with weak base ammonium hydroxide. And so we're going to leave that together. Now some people might split it apart because it is an ammonium substance, and it says in here that all ammonias are soluble, but solubility does not necessarily mean the same as splitting it up into its ions. So leave that guy together because it tells us that it is a weak, and remember weaks and nons never split up. And then we leave that together because this is a pure liquid, and then this one would split into NH4 plus and Cl minuses. So then when we went to the net ionic, the chlorides would cancel out, and then we'd be left with the underlined species right here being our net ionic equation. Okay, and the last one in question 1 is letter D, and that one says a solution of strong base barium hydroxide. And then be careful, barium is +2 right here, and hydroxide is -1, so you're going to have 2. And it tells us it's a solution of it, so we'll put aqueous right there. It reacts with acetic acid, so HC2H3O2 is one way to write acetic acid. To produce barium acetate, so barium goes first, and then acetate is C2H3O2. Barium, remember, is +1, so group 2 right here, and acetate, of course, is -1, it's right up here, so +2 -1. Got to make sure we have 2 of those. And water, so HOH, which of course is a pure liquid. All acetates are soluble, so this would be aqueous. And if you forgot that, you can look right up here, C2H3O2. All acetates are soluble except for silver. And then this would be aqueous as well, would dissolve in water, but careful, it's a weak acid because it's not hydrohexyl high honohexyl OH2SO4, so we'll not split it when we go to the ionic portion. It does tell us this is a strong base, and we know that the strong bases form a B on the periodic table and are the hydroxides of those. So then this is going to be Ba+2 and 2 OH minuses. And this one, as we said, is a weak acid. Remember, the strong acids are hydrohexyl high honohexyl OH2SO4. This is not one of those, so we leave it together. Even though it's soluble, we leave it together because it doesn't split into its ions because it's weak. This one is soluble because all acetates are soluble. So I think I forgot to balance this guy. We needed to put a 2 there, which means I'll put a 2 there. Forgot to put that 2 there before. Should have done that before I started splitting these up. And this is going to end up being Ba+2 and 2 C2H3O2 minuses, like this. And then I end up with 2 H2Os needed over here. So I'll keep a 2 right here. And those stay together because that's a pure liquid. All right. I think the things that cancel out are the bariums here. So my reaction is actually between the OH and the acetic acid, which is an acid-base reaction, just like what we'd expect. And then we'd leave that, and we'd leave that, and that would be my net ionic equation for letter D. Okay, back with the next problem on the practice test in the next video.